Okay, in this lesson we're going to solve exponential equations using what are called logarithms. Now, the thing about logarithms are there's a lot to them, and we are just going to scratch the surface and just look at one use without going too deep into logarithms. There's a lot in grade 12 to cover, and we don't have the time to do a full unit on it. So in grade 11, we're just going to show you how you can use them for one purpose. So one of the main properties, or they call it the law of logarithms for powers, right here, okay, is this. So if you take, log is short for logarithm, and for us right now, there's a button on our calculator that can do that, just like sine, just like cosine, tan. It's a function, right? So we can take the log of something. And what that does is, what we can do is this. So for example, I'm going to kind of take this here and just sort of show it and see what I mean by this. So like, let's say we have log of 2 to the power of 3. Right? Now it's going to give us some decimal number. Don't worry about too much what that number is. So if you go 2 to the power of 3, that's 8, and then you do the log of that, that'll give you a number, okay? You would get the exact same number if you did 3 times log of 2. And that seems weird, right? But log is a special function. So these would actually give us the exact same number. And you know what? I'll pull up my calculator and we'll see if we can just show what that number would be. All right, so let's bring the calculator up here. Here we go. All right, so let's do this first one here, 2 to the power of 3. So everyone knows 2 to the power of 3 is 8, and let's see what log of 8 is. Okay, so we get like 0.9. Now again, you don't know much about logs at this point, so don't freak out. You're like, well, why is it 0.9, right? 2 to the power of 3 is not 0.9, just the log is. Here, get this calculator out of here. Not gigantic. About 0.9, we'll say, right? Okay, let's bring our giant calculator back and shrink it back down. There we go. All right, let's clear that out. And let's do the log of 2 instead. So I'm going to go 2 and then take the log of that, and then I'm going to times that by 3. Notice how we get the exact same number, about 0.9. So we're actually getting the same number out of both of these. So both of them give me 0.9. All right, so we're going to use this property of logarithms without really knowing much about them to do something. Because what did I do here? What this allowed, notice how I took the exponent and I brought it down in front, and I put it here in front. So all of a sudden, I had an exponent here and no exponent over here. So this is, we're gonna, like I keep saying, use this little property of logarithms. What does it allow us to do? It allows us to take the exponent and move it down front like this and multiply it, okay, by the log of that value. All right, so how is this gonna help us to solve stuff? So let's check out some here, okay? So for example, 2 to the power of what equals 64? Now we could all figure this out without, we could probably figure this out in our head, I would hope, right? Without a calculator. 2 times itself, how many times is 64? The answer would be 6, right? 2 to the power of 6. 2 times 2 times 2 times 2 times 2 times 2 is 64. All right, so we already know in the end we're going to get x equals 6. So it's always a good idea when you start learning something new to pick something that we already know the answer to. We already know the answer is 6. Let's show how we can use logarithms to get this. Now again, you wouldn't need it for something so simple, but we're going to need it for ones like this, like 12 to the power of x equals 400. Well, what's that number? What is it, right? That equals 400, because 400 is not a multiple of 12, so I can't just, count up how many 12s multiply to make that, okay? So that's where we really need it. All right, so back to this one. What we do, and I'll walk through the steps and we can kind of speed it up once we get rolling, but let's just talk about what we're going to do. What we're going to do is take the log of this side. So we're going to take the log of 2x, and I usually put brackets around my log because as things get more complex, I'll show you what I mean. But if you do something to one side, don't you have to do it to the other? So whatever you do to one side, you have to do the other. Just like something simple like this. Think about if I have 3 times x equals 15. Well, if I want to divide this side by 3, don't I have to divide the other side by 3, right, to get my answer? So if I take the log of one side, I have to take the log of the other. Now, the first question you might be wondering is, well, why are we even taking the log at all? What's the point of that, right? Here's the point. Once we've taken the log, we are going to use this property right here of logarithms, okay? So what we can do is take the exponent, right, and move it down and multiply the log of whatever we're taking the log of. So in this case, the x is what we're going to move down and multiply, right? So what we ended up having now is x times log of 2. Now we can do the same thing on the other side, but what exponent am I multiplying moving down here? Well, what's the exponent up here? Isn't it just an invisible 1, 64 to the power of 1? So really, I'd just be writing 1 times log of 64. So the 1 is kind of useless in this point. So basically, if we don't see an exponent, we don't have to bother bringing it down, okay? So what do I mean by that? Oops, hang on 1 second here. Okay. So what I mean is we don't even need that 1 there. We can just get rid of it, right? It's useless. Now, if you want to write it in, that's fine. But notice all I'm doing on both sides, I'm taking the exponent, moving it down, taking the exponent, moving it down. So now what we've done is we've put the x down what we call inline. It's in line with everything else. There's no exponents here, right? Everything is in the same line. Everything's at the same level there. So now, how are we going to get x alone? We want to solve for x, so let's isolate x. All right, so we got isolate x, and we end up having to punch in our calculator, what's log of 64 divided by log of 2? So this is a good time to try this out. Try it on this question to see how it's going to work on yours. And I'll try it on mine too, because this calculator, I don't like this built-in computer calculator on Windows. Everything I got to do backwards than my other one. So what I do here is I go 64 log. On your calculator, you probably do log 64. Divided by 2 log, and then hit equals. So notice at the top, log of 64 divided by log of 2. Guess what you get? 6. So there you go, it works. Make sure you can do that on your calculator first before you move on to any other questions, okay? So that's really all there is to it. I'll run you through a few more, but they're all pretty much exactly the same. So here we go. 12x equals 400. We want to know what's that decimal. 12 to the power of what is 400? Okay, so what we're going to do is take the log of both sides. And when we take the log, I'm going to basically skip from the start to this step here, okay? Well, maybe in the next one. I don't want to leave too many behind, but here we go. Log of 12x equals log of 400. So we're taking the log of one side, we have to take the log of the other side. Log short for logarithms. Now, what we can do, and you can do this all in one step. After this question, I will. We take the exponent, we move it down and multiply. So I'd be moving the x out front. This would have an invisible 1, so I'd just be multiplying by 1, which doesn't really matter. So now we're going to have x times log of 12 equals 1 times log of 400. And I won't bother writing that 1. So there we go. So now all I got to do to figure this out is go, what's log of 400? Okay, divided by log of 12. All right, so let's pull the calculator up, see what we get. So again, just be careful how you enter in yours versus mine. Everything's kind of in reverse on this calculator. So 400 log, where you do log of 400, divided by the log of 12. And we get 2.4111. So what I want you to do when you're doing this homework, we're going to write it down to the thousandth decimal place. So tens, hundreds, thousands, that's 3 decimal places, right? So let's write down 3 decimal places for everything today on these ones. So 2.411. So let's come back to our thing here, and approximately 2.411. Okay, and there you go. So that's how we can do that without sitting there and just guessing at what this exponent's going to be, right? We don't want to spend all day just guessing at it. All right, so now let's move on to the next one. Now, what's the problem with the next one? Well, the problem is what we want to do, and it was similar to the previous lesson, is for this to work, we want to have one base on each side. Notice how we had one base, one base, one base, one base. This has 2 bases, 5 times 1.08 and 14.9. So we need to get rid of that 5 first. We need to isolate the 1.08 to the power of x. So our goal is, let's make sure we isolate the base that has the exponent on. So that highlighted 1.058 or 1.8 is what I want to isolate. So I'm going to start by dividing both sides by 5, right? Divide this side by 5, it cancels out. And we end up with 1.08 to the power of x equals, now I'm not going to worry about what this is. You can punch in your calculator or not. I'll just do it at the end. Okay, so now we're going to take the log of both sides, and I'm going to do the 2 steps in one. I'm going to drop the x down immediately this time. So I drop the x down, and I do the log of 1.08, and the log of the other side, that 14.39 divided by 5. All right, and then we just isolate the x by dividing both sides by log of 1.08. So we got the log of this guy divided by 5 and the log of 1.08. Now, a lot of what you're doing here is you're just basically, the point of this lesson is just to get you comfortable with using logarithms to solve for exponents. So you need to make sure, you know, by the end of this lesson, you can solve for the exponent. They're not ultra complicated. It's mostly just some calculator work, okay? So that's really all you're doing here is just using your calculator. So let's bring this guy up. Okay, let's clear out our previous answer here. All right, so I'm going to go 14.39. I'm going to divide that by 5. And I get, oh, it wasn't such a bad decimal. There we go. Let's do the log of that. And then we're going to divide that by 1.08 and take the log of that. And we end up getting about 13. So we're going to write down to 3 decimal places. So 735. There you go, 13.735. All right. approximate. So let's indicate that with our equal sign there, that is approximately equal. And there you go. All right, let's just do a couple more, and this is a pretty short lesson. That's going to be about it. Okay, I've got a couple more here. And again, let's just take a moment to reflect back to the previous lesson. Why can't we do what we did in the previous lesson? Remember in the previous lesson, we could set the two bases the same? So in this case, I can't make 10 into base 2, right? Because 2 to the power of what, right, equals 10? Well, without getting into decimals, right? So it's not an efficient way of doing it. So instead, we're going to use logarithms. So what are we going to do? Take the log of both sides, log of 2, right? And we drop down the exponent and multiply. We can only do that when we're taking the log, right? So I'm going to drop that down. We're going to get 3,217. Okay. Now, what about the other side? We are going to take the log and drop down the x. So log of 10, and you can drop down the x there. So we'll take that x and drop it down. So in this one, we had 2 exponents we could drop down. So there you go. So now I want to get x isolated. So what are we going to do? Just divide both sides by log of 10. 3,217 times the log of 2 divided by log of 10. Now, if some of you are wondering, could I have just left this as 2 to the power of 3,217 and taken the log of that? Yes, you can, because if you look back at that original property we talked about, they're the same thing. But I like to do it this way. So here we go. I'm just going to flip it around, pull out our calculator, and see what we get. Here we go. I know it's boring watching me do a lot of calculations, but really that's what this lesson's about. Making sure you really understand how to use your calculator. So log of 2 times 3,217. Okay, and I'm going to divide that by log of 2. Oh, it should be log of 10. I got to clear this out. Sorry. I made a mistake. I wrote log of 2 at the bottom there. I'm sure you guys caught it already. Let's fix that. That's supposed to be log of 10. There we go. All right, sorry, boring. Let me do it again here. 2 log. Oh boy, am I doing this right? I'm getting nervous. 2 log, there we go. Yep, times 3,217 divided by 10 log, and guess what you get? There you go. 968. Oops. 968.413 approximately. There we go. All right. Let's just do a couple more and then we're ça c'est fini. All right, this next one, same thing. Let's take the log of 5. Take the log of 4. And drop down this exponent. Now let's be careful. We're dropping down the entire exponent. So when we do it, we're multiplying by 1 minus x. So we have to write that whole expression in a bracket. Okay? And we want to get the 1 minus x alone. So leave the 1 minus x here and divide both sides by log of 5. Now I can get rid of those brackets at this point in my solution, right? Because they're not needed anymore. Okay, so we can pick a couple different ways, right? Like we can calculate this first if we want. But the idea is we have to get x isolated. So what I'm going to do is I'm just going to move the x over to this side and move the log 4 divided by log 5 over this side. So my answer is going to be what's 1 minus log 4 divided by log 5, because I want that to be a positive x. So I'm just kind of doing the fewest amount of steps I can. There we go. Right? Add x to the other side, subtract log 4 and log 5 from the other side, and there you go. All right, so it's calculator time, right? We're going to end up getting, let's pull the calculator up here again. All right, clear out our answer here, and let's be careful. All right, so we're going to go, I'm going to do the log 4 first. So 4 log divided by 5 log, and we get this number. So I just need to subtract that from 1. So I'm just going to go minus 1, and we just need the positive version of this answer, right? So not negative 0.13, but positive 0.1386. So we're going to say it's 3 decimal places, 0.139. All right, 0.139 when we round it. So there you go. All right, final one, pretty similar to the last one. Let's roll through it real quick. Same idea, log of 3x minus 1. Oops, no, what am I doing? Going too quick. Log of 4, log of 19. And again, logs allow us to drop the exponent down and multiply. So we're going to drop down 3x minus 1. So this one's very similar to the last one, just a couple more steps to do, right? So let's isolate the 3x minus 1, just leave that here, by dividing both sides by log of 4, which cancels it out on the left side. And here we go, log of 4. All right, so now what am I going to have to do? You can calculate that right away if you want. I'm just going to wait. What do I have to do to get rid of the minus 1? I'm going to have to add 1. And how am I going to get rid of multiply by 3? Divide by 3. So x is going to equal log of 19 divided by log of 4. Then we are going to add 1 to that. Then we are going to divide by 3. So there's what I'm going to do. A little sloppy. Let me clean that up. There. This looks a bit better. All right, so let's punch that all in, right? All right, so so we're really just, for the most part, just solving linear equations after we use the logs, right? Here we go, clear. All right, let's do this. 19 log divided by 4 log. All right, equals, we got that. We're going to add 1 to it, and we're going to divide it by 3. And what do we get? 1.041 approximately to 3 decimal places. So there you go, 1.041. That's the mystery decimal number that we would put up. Remember, that's the whole point of solving. What will we put in for x up here? When we times it by 3 minus 1, do 4 to the power of that. That's what will give you 19, right? Okay, so that's all there is. So this is just making sure you really understand how to solve these. They're not super complex, but the idea of using a log. There's a lot of stuff for those of you that go searching into logarithms. Maybe some of you have used them much more and got into the depths of all the different things they can do. For now, like I started, we're just using the logarithm law of powers. So that's just one rule of logarithms, and it's really one of the more useful things when you're starting in math, okay? So just focusing on this rule for now, okay? All right, so give the questions a try and ask questions if you have them.